Hi everybody, welcome to this module, Working Creatively with Cultural Heritage Data on paper and in Python. So I'm going to go through this, just want to make this presentation mode. Great, so it looks better, thank you so much. So this isn't a code-heavy school. The emphasis of this school is how to engage people with cultural heritage data. But we think there is scope to use code to engage people, to show different things about data we might not have known, to get summary statistics can be useful with some caveats around the limits of statistics to represent the world, especially if it's in the absence of grounded understandings with communities, for example. Um, we know that data is contentious. We know that when states decide to end the collection of certain data sets, such as those relating to COVID or unemployment or the climate crisis, that can create real tensions, real problems around our understanding. So I want to go through a few simple things in this video, how to start coding in Python. We're going to use something called Collab. It's particularly easy for teaching, particularly easy for learners. It doesn't require complex setup, though be aware you can run Python on your own computer, your own laptop. But for this exercise, for this module, we're going to do it in the browser, much simpler. And we'll look at using some simple modules, which are ready-made units of code, which can really save us time and help us to do quite complex things in a reasonably simple way. So that's what we'll look at. So first of all, every coding exercise always starts with hello world. And I'm going to just can even copy that. I'm going to now share a Collab page online. So to use Collab, let me just show this page again. To use Collab, you have to have a Gmail account, and I understand not everyone wants to do that. And if you don't want to do that, don't do it. Work in a group, see how this works. There'll be people in the group who know how to run code through a terminal on locally, and that's another way to do it, and that's something you can discuss with participants. But when you get to when you open Collab, if I say Collab in the browser, I've already got some code there. So I'm going to go File, New Notebook in my drive. So it's going to be on my drive. And so it will take a little while to load. I hope you're seeing that. And here, straight away, I'm just going to make sure you're definitely seeing the same page as me. It's awful when you find out that you're not sharing the right page. So that should be the right page. So we can see that there's this arrow. It's a bit like a play arrow on a tape recorder, and it's ready to run some code. So if I wrote this code, if I go print and then brackets and then go back into the brackets and go hello, it should print hello for me. It'll take a little time to process it. It's executing it, and it should come out. Yep, there we go. So it's not spectacular, but it's the classic hello. In fact, it should be hello world. Almost all coding always starts with hello world. It's the classic way to print an output to the screen. Very useful for lots of different reasons. Might be results of some analysis we've done. It might be a text-based thing where we want to see something printed to the screen. It might be a way to test our code is really working. So to add another block of code, it tends to be broken down into blocks. This is a Jupyter Notebook format. It's a very useful way to learn. And you can move them around. There's arrows here. I'm going to move this back to the start because I'm going to have an import statement there saying that I want to use a program called a module called PyJokes. I'm just going to go back to my screen to my PowerPoint so you can see. So I'm going to import. I'm going to have to install it first. So I don't have PyJokes ready. So I'm going to use a command called pip install, which means use the Python installer to get this library called PyJokes. Let me just check that I'm properly. Pip install PyJokes is the command. So I'm going to go back there. It doesn't want me to, so I'm going to do pip install PyJokes. PyJokes. Make sure I spell it right. If I've got a mistake, it won't work. So I'm just going to hope that works. Pip install PyJokes. Looks like it's working. Yep, it's installed PyJokes. So installing is one part of this process. Now I'm going to add some more code by pressing the plus there, and I'm going to say import PyJokes, which means make PyJokes, this whole library, ready for me in my code here. I've installed it, so it's in the background, but it won't be ready for me to use until I import it. Two different things: installing a library or module, set of modules, and then importing it into this specific code so it's ready for me. I'm going to delete this block of code. We don't need to say hello world anymore. So now I've got this. I'm going to go here. I'm just going to remind myself of the commands. I could in theory go to the PyJokes API, which is the application programming interface, the place where we find out about code. I might go look here. PyJokes. Let me just see if it opens up. Yeah, it does. So just make sure you see this. So I'm going to stop sharing, make sure you're seeing what I'm seeing. Every ready-made set of code or library has this. It's called an API, but it's a place where we can understand. It's very simple. This API, this library of jokes is really, really simple. It's saying here how to install it. I used pip and it just worked. And here what I can say in Python here. So I've imported it. So now I'm going to say print some jokes. I'm not going to use this command. I'm just going to see if I can copy and paste just because I'm lazy. Yeah, okay. So I'm going to make sure you're seeing this proper page. I really want to show you why we even use code, why it's useful. A lot of the time, it's because we're using, whoops, I need code, not text. It's because we're using something someone else has made for us, and it's really simple and convenient for us to use it. So here is jokes in, is that German? Let me just see, without this part, this argument. Yeah, we'll get jokes in English. They're not very funny jokes. But I haven't written these jokes. I haven't put them into the code. It's a ready-made library which I'm using. And this is a trivial example, but there are really good examples of very useful things we're going to use in Python. Now, I want to use this example to show you something else that's very, very useful for us, and that's looping. So what if I want to get 5 jokes instead of just the one joke or all the jokes? What if I want to say I only want a certain number of jokes? Well, that's where using a loop is going to be really, really useful. What have I done there? So I'm just going to go back to there. Okay, they've got they have a really useful example. So if we want every single joke, we can do what I've just done. But I'm going to create a kind of a list. For some reason it's not letting me copy, which will be really useful for us. Just going to be plain text. Put it to plain text. Okay, there we go. That should work. Probably didn't like the formatting of it. So when I go, oh God, when I go like that, okay, copy. Really amazing bug here. Sorry, code. Okay, so now I've pasted some code in. I'm going to remove this. You can tidy it up. Just going to remove this and then add more code, not text. Okay, so now I've created something called a list. What doesn't it like? Oh yeah, got to create my joke list first. So I'm going to create a jokes list, a list of things that are from the jokes library. And then I'm going to say how many of them I want. I don't want all of them. There are quite a few jokes in the jokes library. I think I'll go back to this. So I'm going to add some more code here. Okay, so I'm going to say, yeah. So I'm going to say for this list of jokes, for this PyJokes library, get all the jokes and put them into a list called jokes list. And now here, I'm going to say, I want 5 of the jokes from that jokes list. You see here, so this is a for loop and it saves us a load of time. I could go print PyJokes 5 times, but instead I'm going to just say in this automated piece of code, this automation, here I can say get me 15 of the jokes from this list of jokes that I have. So you can see here It just means for the jokes in the jokes list, get me 15 of them. 0 to 14 it would be. We're not we haven't put numbers next to it, but it would be 0. The thing at 0 and the thing at 14 is 15 lots of jokes, and then print them for me. So it's really useful to use a loop, a for loop, instead of having to do it 15 times myself. Very, very useful piece of code. So we also created, we can also create a variable. For example, we could say, okay, we're going to create a variable called A1, and A1 is going to be some jokes in our jokes list. I keep having to convert this to plain text. Okay, and I'm going to say, I'm going to add some more code. I'm going to paint that here. I'm going to say A1 equals get me a joke in English. And there are 2 categories, there's neutral and there's code related jokes. So now I've got this variable called A1. It's holding values. It's a data structure. It's holding the result of this command. And now if I add another one and I can say print A1, I should see my code, my jokes. Yeah, there you go. I'm seeing my joke. So that's a variable and a loop and the use of a library that we've covered so far. So now we're going through a lightning crash course in Python. Why Python? Python's the most common language for data analysis, for natural language processing. I would say also for machine learning. It dominates the world of data analysis. There is another language called R, which is a little bit more high level. It covers some of the complexity. It's fun for data visualization, but I think Python, is the most dominant language for data analysis. So that's the language that we'll be using. Let me see, and certainly something a little bit more complex, and I'll explain it. It's more fun as well. I'm just going to convert it to plain text for some reason. Not surprisingly, copying from the PowerPoint, Collab doesn't like it. It's full of other stuff. I'm just going to make sure you're seeing what I see by stopping and then sharing again. It's just a fail safe to make sure you're seeing the same thing as me. So I'm going to create another code block here. I'm going to paste what I just wrote, but actually I'm going to remove some of it because I want to deconstruct it in a way that makes sense into these chunks, into these modules, and tidy them up. So I'm importing something called random. I don't need to install it because it's part of the Python library. Sort of there always. It's such a useful library that we use it all the time. I'm going to repaste that in just with the body of code. So actually I'm just going to print this part. I'm going to get rid of that. So what we have here, I've created a set of arrays, and arrays are these comma separated. They're like lists. They're set lots of different things separated by commas. And I've got a sentence starter. I've got a character, as in a dramatic character, as a character in a story. I've got a time of day. I've got a story plot, and I've got a place, and then a second character, and then I've got something they're going to see, and then I've got something they're going to do. So I've created these data structures, and there's nothing to see yet until we then use them in our code, and that's this end bit. And I'm just going to say randomly choose something from the starters list of starter things, array of starter things, randomly choose a character plot or choice, story plot. So you can see I'm randomly putting these elements together, and here I've got a cheap little story. A cheeky little story. In the 20 BC, there lived an artist. One full moon night, they were going on a journey to the mountains. They saw a wolf. It was a beguiling sight. They decided to create a memorial to it. It's really simple, but it really helps us to understand a few things. We've created these different arrays of different ideas around characters, times. And here I just say random. This is here, this random library dot choice dot choose something from the sentence starter, and then add a random choose from the character array, and then add with this plus, we're adding it all together, a random choice from the story plot, a random choice from the characters, the second characters, and then something to see, and then something to do. So explore this, play with this code. Doesn't matter if you break it. You can add more things to this, change all the things, change the order, see what happens. A really good way to learn how to code is to break the code. Now listen, I know some of you in the group will have more experienced than others. Some people are experienced, some people aren't. Let me just share the PowerPoint to make sure those of you who are very experienced coders will know that there are some more complex tasks for you. There is intermediate as well as more challenging tasks. I don't want you to use ChatGPT. I want you to demonstrate your understanding and to learn by doing tasks. When we use Gemini or ChatGPT to code, I seriously don't think we're learning how to code. I think if you're an advanced coder, they can sometimes. I do sometimes use it when I'm pushed for time. I don't like myself using it, but I understand the code and it can make me do things really quickly. But when you're learning to code, I don't believe there's any learning involved in doing copying and pasting. I don't believe people go back over it and learn from it. So I don't want anyone to do that. But if you're an advanced coder or an intermediate coder, here are some more challenges for you. So have a look. They're in the back of the PDF. I don't want anyone to be bored. I want you to do something that's interesting to you. So do these tasks if you're used to coding, and share with your group what it was you learned, what it was you did, what it was you discovered by using more advanced and analytical approaches. So we've used the library already, and we've used a variable, and we've also created stories. Let's have a look a bit more at what this idea of a variable is in all languages, actually. So let's create a new variable. I'm going to go back to the code, and I'm going to show you how we can do a range of different things with it. So here we are. Let's just say here, I'm going to add some more code, age. So I'm declaring a variable called age. It could be called anything. Age equals 32, certainly not my age. I'm just going to run it to make sure it works. Run code as you go along so that if there's any errors, you'd immediately know where it was in the code. So I know that works. So I'm going to go age 2 equals age times age. So there I'm declaring it, and then I'm going to print it. So I'm going to go print. In fact, I could probably go age 2, and I think I would see it without having to do it. Yeah. So I've multiplied 32 by 32, and it's 1024. Kind of familiar number if you're used to computers and their RAM power. So I didn't need to use a print statement for this. I can just go age 2 equals age times age. What's 32 times 32? I just write age 2 and I've got the result of that. Really, really useful. I can do, you can see I'm creating new variables, equals age 2 divided by 2. What's that going to do? So that's, I'm declaring it, and now print it. I'm just going to write age 3. What is age 3? It's 512. If anyone's used to old computers that weren't very powerful, all these numbers are quite familiar. They're usually the power, the amount of memory that a computer's got on its hard drive. 512 still is actually 124. Then we get bigger and bigger computers. My first computer had something like 8 megabytes of memory, an Olivetti. Amazing, isn't it? So you can see here that Python's also as a mathematical system, as you'd expect, really. A computer is something that adds up. So it's really easy to do maths, and if you've got a Mac, you can use your terminal to run Python by going Python and immediately doing this, and I can do it on my computer because I've set it up to do that. So this is very simple mathematics. It can get much more complicated. You can do you can do square roots, you can do logarithms, it can do all sorts of really complicated things for us. I want to also quickly introduce some logic. So a computer is not very powerful until you introduce logic, and logic means conditions. So I'm just going to get this into a plain text format and then put it into there. And I'm going to use it on our age data. So I'm going to just make sure you're looking at what I'm looking at by going back to the collab. And here I'm going to add another code block. I'm going to put this here. Okay, I'm going to break it down because we have something called input. This is really interesting. So age equals input. Hello, how old are you? What can that be? I'm going to run it. An input means actually an interface opens up to invite my age. I'm going to stick with the fiction of 32. and then I'm going to add some more code, and I'm going to put age int as an integer equals age. I'm going to convert this as a string. This interface is asking for writing. That's not seen as a number until we convert this into an integer, a whole number. And then we can set a whole load of conditions. So I'm running this. Seems to be executing at the same time. I wonder if I lost my connection. Yeah. Okay. I think I lost my connection, so it's going to run this again. I'm going to stop. Yeah, it's going to stop that, and I'm going to run this. And I'm going to put 32, and then I'm going to press return. That's what I should have done. Sorry, I should have pressed return. So now I convert this string. This is a written thing, a word rather than a number. Then here I have to say this new variable, age int, is this variable age, which is a written thing, a string, made into an integer, a whole number. And then I'm using conditional logic to say, if this age is over 40, say, print so mature and wise. As else if means otherwise. If it's less than 40, print so young and fresh, or print wow, you are 40, your life has just begun. Because if your age isn't above 40 and your age isn't below 40, you must be 40. Let's check it again, shall we? Let me say I'm 40, as if only, and then I press enter. Here, wow, you are 40. Your life has just begun. So this is conditional logic. It makes computers hugely more powerful than they would be without conditional logic. So let's go back to the PowerPoint and see what we're going to do next. Okay, so I'm going to do a more complex thing and a more fun thing, and I'm going to show you a variation on Joseph Weizenbaum's ELIZA program. Some of you may have heard of. ELIZA was a bit like an early chatbot. So something I wrote about for my own doctoral research. It's a very interesting program, and Joseph Weizenbaum's a very wise man, as his name suggests. He thought it was really ludicrous that people took it seriously. The rather misogynistic argument is that he showed it to his secretary, who started to have conversations with it and thought it was intelligent. I don't believe that necessarily, but anyway, let's see how this works. So we've imported two modules. We've imported time. We've imported random again. I didn't need to actually, because I used random above here, didn't I? But I forgot and I installed it again. Doesn't matter. And then we're going to have another. I'm just going to break the code down in a logical way. It's always useful to use that. And we can reduce this white space, this unused space. We can push this up to here, just neatening it up a bit. That's okay, that'll do. So now I'm going to run this part. I'm going to import these modules, and then I'm going to get my name. I'm going to put my name here. Remember, I have to press enter for it to be accepted. And then I'm going to put the rest of the code. So there's going to be a bit of a delay, which is, and then it's going to ask me to say, so it says, hello, Eleanor. It's grabbed my name variable, which is a variable because it varies. It might be your name when you run the code. And then it says, how old am, how are you today? I'll say, lovely. Lovely. And then press enter. And it will then say, I'm sorry, chin up, because it's so limited. It's only really looking for me to say happy. Do you see here? If happy, say, I'm feeling happy too. Or else, sorry, print, I'm sorry, chin up. So I didn't put happy, so it's done that. Then it gives a little delay. And then it says, what's your favorite genre of book? I'm going to make sure I match theirs. And I'm going to say sci-fi. And then I press very interesting choice. It says sci-fi. Now it will say, let's have a look. And that's the end of it. And that's a really short little program, very similar to the first chatbot. So again, have a look at it. See what this timed sleep is doing. Reduce it or accelerate it. Change these. See if you can add another set of choices, another branch of logic, which might say, what's your favorite color, or where do you live, or what's your favorite museum, and see if you can add more to it. I hope you can follow this. The best way to see how it works is to break it down, play with it, See what happens when you break it, what happens when you mend it. Do this in your group. It's really useful. So the main thing about Python, though, is that it's really good for data analysis. I want to move on to some quick overview of data analysis. So here we have on this page this idea of summarizing a data set. So we've got a very, very simple data set, and we want to understand what are the statistics that come out of this set of numbers here, this array of numbers. Of course, they could relate to lots of things. It could be people's incomes, it could be people's heights, it could be museum visitors, it could be how many people liked something or hated something. We don't know what it is. But let's just accept that this is a set of data that we've collected. It's numeric, and now we can find out some descriptive statistics, meaning what's the average value, what's the mean, what's the standard deviation, what's the average of the average distance from the average, what's the minimum number, what's the maximum percentile. So let's have a look. So I'm going to go back into Collab, and it won't let me paste it, so I'm just going to make it plain text first, and then I've got it plain text. So back into Collab, add another code block. As before, I'm going to remove this and make sure I've just got import pandas as PD. Pandas is data and a Python data analysis library, and PD is just the name we're giving it so that we can refer to pandas, the library, throughout the coding. You'll see that again and again, and it's usually called PD, though we could call it anything. So here I have this little on-the-fly data set. 3 lots of numbers, 5, 10, 14, etc. So let's have a look what happens when we run this code. So I've made it into a data frame, which is really this structure here, a bit like a spreadsheet as a data structure. And when I write describe, we would not see anything until we write describe. So df is the name we've given our data frame, which is a data structure, and df.describe is the way we see what's happening. If I run it again and comment this out, see the comments green, there's nothing to see. I haven't told the computer I want to see anything until I go df.describe. So here it's given us the mean, add things up and divide it by the number of things, the standard deviation, what's the average number away from the average, what's the minimum and the maximum percentile. Really, really useful. Very quick overview of something. How might we move on from this? Let's see what else we could do. So descriptive statistics summarize a data set for us. It can either be a representation of the entire population of a sample or a little section of something that we're looking at. They're broken down into measures of central tendency, measures of variability, how much of what's going on in the spread of the data. Central tendency is things like the mean, the median, the mode, the most common thing in a data set, the thing in the middle of the data set, the number of value in the middle of the data set, or the mean, the number we get when we add them all up and divide them by the number of things in the data set. Variability, standard deviation, variance, minimum and maximum variables, standard deviation, what's the average distance from the average? Very useful. You'll see an explanation of this in the PowerPoint, in the PDF, so have a look at that if you're interested in more detail. So Python provides us with ready-made approaches to get data calculated, results like descriptive statistics done for us. We don't have to do it ourselves. So if I add this back into my code, I'm now using a different library. Oops, I have to make it plain for some reason today. Just found a plain text editor. So we're going to use SciPy, which is another library. So there's a number of different libraries used in Python. So let's have a look. We've made an array of data, and now we want to see what's the mode, what's the most common number in this data set, and we get 6, and it tells us 6 and 2. Let's have a look. We get the stat.stop mode. Mode result equals 6. It's an integer. Count equals 2. There are 2 things of 6, so it makes total sense. So the most common number is 6, and there are 2 incidents of the number 6. This bit here is just telling us what kind of data, what type of data we're dealing with. And nothing would happen until we said print mode, here's what we want to say, equals, and then the result, which is mode result. So this may or may not mean much to you, may not be of interest to you, but I hope you can begin to see that when we look at things like, let's look at some different type of data. Let's say I've got a load of jokes, and I have collected a load of jokes from a load of different places all over the world. It's a genuine cultural heritage data project, and I want to somehow to count these. They're not numbers, they're categorical variables, they're categories of things, places. So I'm going to import, again, just to show you, see, NumPy and Pandas, two different useful libraries. And I've created this array of different towns according to the jokes, where the jokes came from, or where the person was who told the joke. And you can see that some of them repeat themselves. So I've made a series, which is useful, because I can convert that into a count. I want to count. So I make it into a series so I can count them and then see. Here I've got the counts. So there's 3 incidences of jokes from Springfield, 3 of Rivertown, you can see. And now I want to display them. So the bit that gets interesting is show us as a histogram or a bar chart here. This is the size of it. This is the color. This is the label. Show us a rundown of where these jokes come from. And there they are. Yeah, 3 incidences of Rivertown and Springfield. This is all really explained in detail in the PowerPoint. So I hope you'll go back and see how we can do this, but also how you could then export this as this new data, the counts, as a CSV file and import that into something like Flourish, which is a pretty nice place for designing data visualization. So I'm going to add some more code and going to paste that in. Sorry, I have to make it plain text first, could be a bit of drag, but it might happen to you, so it's useful for you to know that I'm doing this, converting it into plain text. Now here, I've declared a CSV file, and you can see it automatically downloaded. So all these counts, this very simple little data set, it could be huge and it could be complex, but it's simple. I've declared something called a towncounts.csv. I've added the town counts to that, and then I'm going to download it. It's downloaded it for me automatically and then confirmed that with this statement. So I have that data set on my computer, and I could now use that in the program, a program like Flourish. Let me just share my screen so you can see. I suggest using very simple data sets to start with, to upload that data set, the CSV, into Flourish Studio, which is online at this link. You don't have to pay for it. Don't pay for it. Might ask for your Gmail or something, but no payment involved. Experiment with different ways of visualizing that data and see what you get. Definitely with really simple data sets. So have a look at this. I'm not going to explain that on the video. I think you can read that in your own time. These are more complicated forms of machine learning, whether it's supervised with a labeled data set, so it's training something from something it can see, as it were, whether it's spotting groups or clusters or relationships in data that has not been labeled, or whether it's more like in robotics, where there's a kind of a system of reinforcement to make sure that desired patterns of behavior are programmed into a system. So be aware of those other things. Okay, so there are lots of different ways to load data into a program, but I'm going to show you the simplest way, which is to upload data straight to Collab on a side panel. Let me just show you what I mean. So there are loads of different ways. We could upload it to our hard drive, to our Google Drive, and have it just there using some of our drive space, or we can temporarily use this space here. So I'm going to drag something. I can use this button here to find something I downloaded earlier on, a dummy set. I've got the town counts data, but it's so trivial I don't want to use that. So I've got some jokes data that I uploaded before. Okay, so it's telling me be careful, it will only be there temporarily. That's a good warning, because as soon as I stop using Collab, that will disappear. It's not on my Google Drive permanently. I didn't upload it to my Google Drive. I uploaded it to this temporary space that Collab provides for us. So I've uploaded it, it's available there. So now I'm going to import it into my program. And the way to do that is I'm just going to share this line of code, which I need to make plain text. You may need to do this. So I'm just putting it into a plain text editor and then copying it from there, because some things that come from PowerPoints are full of extra stuff we don't know. So I'm saying I've cleared a variable. Is it not there? Called jokes. Where is it? Should be there. Jokes.csv. I'm going to get the address here. When you go like this, copy path, this can make sure I've got exactly the right path to it in between these. So I can only think, yeah, okay, that was the wrong path. I had it from something I'd done previously. Good. So then I copied the real path here, put it back in between there, and now it's not broken. So now I think I can just go data, and it would show me, oops, go away. Yeah, if I go data, it's suggesting that I can see it. I can see my data. I can see what's on my joke CSV, comma separated file. I made it in Excel or Google Sheets, and it's just a comma separated file of jokes. It's got the dates, it's got their name. In the PDF, sometimes you'll see the dates as hashtags, not readable hashtags, and I show you how to correct that. It's a simple procedure, but I'm not going to show you that because it might not happen to you. But if it does, follow what's in the PDF showing you how to do that. So that's useful. Now I've got my data, and now I want to I want to analyze it a bit. I want to see what's going on in it. Let's have a look. So I'm going to start to visualize something from it. I want to find out about the joke lengths. What's the average joke length? That really interests me. But first of all, I'm going to shut that, and that's just hidden now. I'm going to import a library. I'm going to import the matplotlib, which is a more sophisticated data visualization library, and Seaborn, which is also a sophisticated data visualization library, just like how it works. So I've imported them. I don't need to install them. They're implicitly available to us through Python, because they're so common to use. So now I'm going to count the average length of my jokes. Just want to know, just make it plain text. So first of all, I am going to data joke length. I've created this variable equals data joke dot apply length stands for length, and then display this. Let's have a look. So it's telling us here the joke length. So I've created a new column just showing us the first 5. 0 to 4 is 5, and I can have a sense of what the length of jokes are. But let's have a deeper understanding of what's going in here. Let's have a look. Let's actually visualize some of these joke lengths. Let's have a look at what the general spread is across my data set of jokes. So I'm going to plain text, make that into plain text, copy it, paste it in, and you can be doing this with whatever data you have. So I've decided how big I want my figure to be, and I've said I want to simplify it to 20 units. Okay, and I want it to be blue. I want the title to be distribution of joke lengths. I want the joke one label to be joke length characters, the other label to be number of jokes, and I've plotted the color and made it show here. Experiment with this. There are many other colors. I'm just going to guess. I've listed them in the PDF. I have guessed that there are, that red is one of them. Yeah, so it's 20 bins, 20 of these. It's including the missing ones where those values don't exist. If I put 40, I don't know what it would look like. 10 would, I presume, just simplify it. Yeah, it's really simplifying it. So you can get a more refined, if I put 40 40, what would that be like? Does it make sense? I don't know. I haven't really. Yeah, so it's a finer. It might make more sense if we ran a line across this, which is what happens here. If I put true here, we might get a better sense of the overall sort of shape of this data set. This line here, is it finer when we have more bins? These are called bins. As in music, if you have less data, the music can be less high resolution, as it were, less faithful to the original sound. It's reducing the resolution, the number of bins. If we put only 5 bins, let me have a look. Sorry, it was here. If we put 5 bins, it's going to be really crude, like a bit like early JPEGs. Yeah, like this. And more dramatic, the curve as well. So that's really interesting to see that. So we've imported our data set, we've visualized it, really, really interesting. And here we can see the number of different colors we can use, and we can also run data analysis through it. So I'm going to try and find out what the descriptive statistics are on my joke set. So go back to Collab, just going to share that with you. I want you to experiment with this and not be frightened of breaking it, and work together to understand what on earth is it showing us. I'm just going to make that plain text. Okay, I'm going to go back in, and I've got my joke length data. Okay, so the median joke length is 57.5. The mode, the commonest joke length, is 55, and the mean, the average, is 58.9, or the total that added them all up and then divide it by the number of jokes. And the one in the middle is 57.5 in length. Interesting. Potentially, if you're that kind of analyst, maybe it's important data. People do that. And you can also then export that data set as we did before, get it into Flourish, find out more about what's going on in your data. I'm just going to go back to the PowerPoint. So this is very basic, but I hope it shows you how we can automate certain tasks with loops, how we can quickly get summary statistics. I've shown you quite trivial examples, simple examples, but of course it could be really complex data. And here in the PDF are some amazing repositories of digital humanities data. This one's got an enormous amount that you can explore, all sorts of different connections as well as all sorts of different data sets. Melanie Walsh has the most fabulous tutorials if you want to go deeper. Here, her Irish immigrants admitted to New York City's Bellevue Almshouse, a data set that tells many, many stories of ambition, poverty, hope. All life is there in that data set. So menu data sets are really, really interesting. I hope it's useful. It may be useful to find the most common word in a data set without an at and. So there's methods for doing that here. They're really simple. I hope now you can see how you can copy and paste this into Collab, break it down into meaningful chunks, run it sequentially, and see what you can get that's useful. See what happens when you look at language without at or the or whatever's the most common word in any particular language. Very, very interesting visualizations. Sentiment analysis, be very, very careful. It's considered to be pseudoscientific, extremely crude, extremely, in some ways, extremely dangerous if people start making assumptions. For example, this Processing P5 has a website about the dangers of sentiment analysis, and it shows that bizarrely, the sentence "each of the families has a gay son" is 95% positive. Each of the families has a gay daughter is 36% roughly actually negative. So very strange to think about the logic of these evaluations. Where do they come from? Be really, really careful around emotion and sentiment analysis, or whatever it's called, sometimes both. It may tell us something more about computer science than it does about people. So the last thing I want you to do, if you're interested, look at Turtle Graphics. Turtle Graphics was really invented as a pedagogic tool to teach children and adults about logic. It comes with a whole historical context, which Barbara Hoff writes about so brilliantly in her essay, The Turtle and the Mouse, how constructivist learning theory shaped artificial intelligence and educational technology in the 1960s, a history of education. Very, very interesting. Highly recommend this paper. But have a look at this. Use this interface here to run this code. It won't work in Collab, interestingly. The rendering doesn't work in Collab. Play with this, go through, see if you can work out what's going on, see if you can produce something interesting. Drawing with code is surprisingly useful, even the earlier code, when you're trying to work out what it is you want. Drawing and making notes, diagrams can really help you, especially flowcharts. But in this case, you may find that drawing, if you make some squared paper yourself or find some, is really going to help you understand how to plot what you're seeing to your idea beforehand. So I highly recommend using that as well as using paper to work out what it is you're trying to do before you start coding. That can be pseudocode or actual diagrams. Pseudocode is human language for really understanding the approach to to break down like a recipe what it is you're trying to do, can really clear your mind around your code. Amazing how many students have come to me with code, and I say, but they say, help me, my code doesn't work. And I say, but what are you trying to do? And they say, I don't know. And I'm like, if you don't know, I don't know. Write down what it is you're trying to do, as if it's an instruction to someone else, to go down to the shops, turn left, take £5, go down to the shops, turn left at the main road, cross the road, go into the red shop, buy a bottle of milk, come back. This is the kind of level of thinking clearly around what it is you're trying to do, whether it's analyzing data or drawing something on the screen. So I really like this purple turtle graphics. Really enjoyable, really interesting, but really part of our computational cultural heritage data. When we look at these systems, who designed them, what were they designed to do, is a very significant. The final part is about analyzing images. Again, now that you've seen how Collab works, you should be able to take any code, use it in small sections, build it up, and then work out what it's doing. This idea of understanding human emotion, whether it's through images or through language, is very, very controversial. And I've discovered it can be incredibly erroneous and presumptive and dangerous in its generalization. Finally, we must honor Muhammad ibn Musa al-Khwarizmi, who invented the algorithm as well as algebra, a brilliant all-round thinker, a polymath from, not quite clear whether it's Iran or Uzbekistan, but I always like to take time out to acknowledge this incredible invention that's been around for a very, very long time in human history. It wasn't invented by Americans in the 1970s, for example. So have a look at that if you're interested. Your main task really is to think about the ideas in this presentation and in the PDF, and how might that relate to public engagement? Would it be helping people to work with a particular data set, whether it's the immigrants data set from America and working out stories that come from that? Or would it be doing turtle graphics and understanding the history of computation? Think about what it suggests to you in terms of stories. And if you're advanced or intermediate coder, please do have a go at these. I've spoken for a long time. I hope you find it interesting. Work together. There'll always be somebody in the group who knows something, whether it's how to draw, whether it's how to find the data set, whether it's how to get rid of the hashtags where the dates are. Work together. And let's also not forget that regression to the mean, statistical significance, Pearson correlation, Fisher's probability come from eugenic, white supremacist, racist ideologies. It's incredibly problematic, more than problematic, devastating, damaging ideology. Have a look at this paper by Aubrey Clayton, which makes it absolutely clear that these mathematicians were white supremacists, and unfortunately their ideas still dominate AI ideology. I would say underpinning most CEOs in American corporations are white supremacists, eugenicists, and proud of it. So we have to be really careful around what quantitative data can do and can't do, and be highly alert and self-aware to the dangers of generalization, especially around things like cultural heritage data, emotion, gender. I hope I will have time to show you how I can turn gender on and off with a smile, because the algorithm is so crass, or rather the data set is conducive to a crass understanding. So thank you very much. I don't want to leave on a negative note. It can be really enjoyable to work with code. I've done it since about 2004 and find it extremely fascinating, rewarding, sometimes frustrating, but very, very interesting, never boring to work with. Thank you.